Okay, so today we're going to use the same formula again. Actually, the first thing I want to change is the plus to a plus or minus. For some reason I thought that. Same exact formula. I put amount of time, that was our old T. Length of cycle or period of cycle, that's our P. So we're still keeping the same formula, but you're going to see this change slightly today because yesterday our length of cycle seemed to always be 1 week, 1 year, whatever it was. Now we're going to look at maybe a 10-year rate and have to change it to a 2-year rate or a 1-year rate. So let's just jump into exercise 1. A population of wombats is growing at a constant percent rate. If the population on January 1st is 1027 and a year later is 1079, what is its yearly percent growth rate to the nearest tenth of a percent? So they give us a starting population and a final population. So this would be A sub 0. This would be A. That happened a year later, so that was the amount of time. T equals 1. What is its yearly percent growth rate to the nearest tenth of a percent? So we're looking for R here. So I will just go ahead and plug in my values. 1027, 1 plus, it's definitely growing, some R value to the 1 over, and they're still looking for the yearly percent growth rate, so they want that to be yearly as well, so that's still over 1, and this all equals the final 1079. So we'll just go ahead and solve that, dividing by 1027 on both sides. That'll get rid of that. This is being raised to the first power, so you can pretty much ignore that. So 1079 over 1027. I'm afraid of that decimal, so I'm just going to leave it. Just equals 1 plus R, and then I'm going to subtract 1 from both sides. So on your calculator, just 1079 divided by 1027, and then subtract 1, and that gives you R, 0.0506. So if R equals 0.0506, what is that to the nearest tenth of a percent? So that's 5.06%, which to the nearest tenth of a percent is 5.1%. Okay? Now, they're saying let's try to determine what the percent growth in the population will be over a decade. So we will assume that the rounded percent increase found in exercise 1 continues for the next decade. So we're keeping 5.1% for the next decade. So that's our new R value. But now we want to know what is the growth that's going to happen over a decade. So if we still start with an initial value of 1027, 1 plus 0.051, we want to wait. That growth rate was per 1 year period, so 1 year, and they want to wait 1 decade of time, which is 10 years. Here's a key thing about this formula. These both have to be in the same unit. So even if they say 1 decade, you wouldn't use 1 here. You would use 10 years because this is in 1 year. And then we're going to look for the final amount. Or if you want, we can even keep that a capital A. So I'm just going to type that in. Now that's going to give me the final amount. So I don't think it'll be the answer. 1027, 1 plus 0.051 to the 10th power. And I get 1688.875. So A equals 1688.875. So that's the final population. That's the start. So this is now going to go back to Algebra 1, maybe even pre-algebra. What was the percent growth here? From 1027 to 1688, what percentage did it increase by? So 1027 increased by some percentage of 1027, and it became 1688.875. So there's the original starting amount, and it increased by some percentage of itself, and it became 1688. So we'll figure out that percentage rate by subtracting 1027 first to get rid of that on that side, and then dividing by 1027. So x will equal second. 1688.875 minus 1027 divided by 1027, and it grew by 64% over a decade. So 5.1% per year, keep growing by 5.1%, is overall a growth rate of 64% in the decade. What you should notice is it's not 10 times that amount because it's 10 years of this. It's actually more than 10 times that amount. So take that answer, and I'm actually going to show you quickly an easier way to find that. So over here, if you know the 1-year growth rate and you just want to change it to a 10-year growth rate, just type that into your calculator. And you'll take this 1-year growth rate and watch what happens when you just type that into your calculator. 1 plus 0.051 raised to the 10th power. 1.64, look at that decimal compared to what we got before. So rather than doing all the work that we did, all we have to do moving forward, if we want to change the growth rate that we know is a 1-year growth rate into a different unit, just change that up top and type that in, and you'll see, now the 1 is from the 1 plus, but the growth rate is just this additional decimal, 0.644. It's how far away from 1 is this number? Well, that's 64% above 1, so 64% growth. Assuming their growth rate is constant over time, what is their monthly growth rate? Okay, so again, right now we have 1 plus 0.051 to the t over 1 year. Okay, they're looking for us now to change this to a monthly growth rate. I can't just put 1 month here because months and years aren't the same if I want to change it to a monthly growth rate. I can either convert 1 month to how many years so that they're both in years, or I can keep this 1 month and I can change this into its equivalent in months. So if you did it both in months, it would be 1 month as your T and 12 months as your period. Or if you did it both in years, you'd keep the denominator 1 year. And how many years is 1 month? It's definitely not 1 full year. 1 month is only 1/12 of a year. So half of you can plug in this raised to 1/12 if you convert to months, or the other half can, if you convert it to years, would still be raising this to 1/12 over 1, which is still 1/12. So either way, you're raising it to 1/12. The key, though, is understanding that these units have to be either both in months or both in years. So I will just do the top one, 1.051 raised to the 1/12th power. And my monthly rate is 0.00415, which has a decimal, move that over twice, is 0.415%. So not even quite 0.5% on a monthly basis, which makes sense. If it's 5% on a yearly basis, you know, it's not even quite 0.5% on the monthly basis. In exercise 4, we have a population growing at a constant rate of 22% every 5 years. So 1 plus 0.22 t over, and that rate of growth is happening over a period of 5 years. Then what is its percent growth rate at the 2-year time span? So if we want to figure out what the growth rate is at the 2-year time span, we're just going to plug 2 years in up there and type that into our calculator. 1.22 raised to the 2/5 power, which is 1.0828, we'll say, which, how far away from 1 is this? 0.08. So R equals 0.0828, which as a percentage, move that over twice, is 8.28%. every 2 years. So every 2 years, it's growing by this. Every 2 years. Okay. If I wanted to, I could even now, if I wanted to use the 2-year rate instead of the 5-year rate, I could rewrite an equation using that rate. It would be 1 plus 0.0828 t over 2 years. Okay. And then this is the 2-year rate equation. This is the 5-year rate equation. But they're both, technically, they will be both the same equation. If you plugged in 50 for t in both of these, it'll give you the same thing, because growing by 22% every 5 years is equivalent to growing by 8.28% every 2 years. Okay, world oil reserves are depleting at a constant 2% per year. So 1 minus 0.02 every 1 year. So t over 1 year. We would like to determine what the percent decline will be over the next 20 years. Just plug in 20. So that'll be a 20. So we're going to have to 1 minus 0.02 raised to the 20 over 1 power. Now, this is a little bit trickier. How far away from 1 is that? So that, let's just call that 0.67. So 0.67 became our new base, t over, and that's our 20-year plan. So if you're thinking backwards, what would have the rate have been that was subtracted from 1 that would give us that? So really, how far away from 1 is that number? So if you just subtract 1, that'll be a negative. Ignore that. It's just 33%. It's a 33% decline. So R equals 0.33. So a 2% per year decline is a 33% every 20-year decline rate. Those are equivalent rates. So what percent decline? 33%. So if it's greater than 1, it's how far above 1 is the number. That'll give you your rate. If it's less than 1, it's how far below 1 is the number that will give you your rate. All right, half-life. I'm not sure if you've done half-life in science, but it's the amount of time it takes for only half of something to be remaining. So let's say we have a radioactive substance with a half-life of 20 years. What that means is it's losing 50% of its quantity every 20 years. So this question is, what is the percent of the substance that would be left after 40 years? You would just plug in a 40. Okay, so 1 minus 0.5 raised to the second power. 25 is your base. So that's now your 40-year decline rate. So what was your R to the t over 40? Your R would have been 0.75. So 75% lost, right? So if you actually answer this question, it's worded differently. What percent would be still remaining is what it says when it says would be radioactive. So if 75% was lost, then you only have 25% remaining. And they could ask either question. How much percentage did you lose over the 40 years, or how much percentage is remaining? You can be prepared for either. Actually, this number gives you how much is remaining, and the R that you kind of have to think backwards on gives you the amount that was lost. What percent would be radioactive after only 10 years? So 1 minus 0.5 t over 20, that's our 20-year half-life, losing 50% every 20 years. They want to know what happens at the 10-year mark. So that's just going to be 1 minus 0.5 to the 10 over 20, which is 0.71, we'll say, just to keep it nice. So that's 0.71. Now we've converted that to the t over 10-year mark. And so